Hey there, data enthusiasts! Welcome back to our channel, where we dive deep into the exciting world of data science and machine learning. I'm so glad you're here today, because we're about to explore a fascinating topic that's essential for anyone working with data, DBSCAN. Now, you might be wondering, what exactly is DBSCAN, and how does it work? Well, you're in the right place. Today, we're going to break down this powerful clustering algorithm in a way that's easy to understand, even if you're just starting out. So, grab your notepad and let's get started. But before we dive into the details, let's start with a key question. Why do we need clustering algorithms like DBSCAN in the first place? Clustering helps us group similar data points together, which is super useful in many fields like marketing, biology, and even social media. So, how does DBSCAN fit into this picture? Let's find out. DBSCAN stands for Density-Based Spatial Clustering of Applications with Noise. Wow, that's a mouthful. But don't worry, we're going to break it down. At its core, DBSCAN is a clustering algorithm that identifies clusters in data based on the density of data points in a specific region. Unlike other clustering algorithms, like k-means, which requires you to specify the number of clusters beforehand, DBSCAN automatically finds the number of clusters based on the data itself. This makes it super flexible. So, how does DBSCAN determine what constitutes a cluster? It uses two key parameters, EPS and minute points. 1. EPS. This parameter defines the radius around a data point. In simple terms, it's like saying, how far out should we look to find other points that are close by? 2. The minute points. This parameter defines the minimum number of points required to form a dense region. Think of it like a threshold. If you have enough points within the EPS radius, then you've found a cluster. Now, let's walk through how DBSCAN works step by step. 1. Start with an arbitrary point. DBSCAN begins by selecting an arbitrary point in the dataset. 2. Find neighbors. It then looks for all the points within the EPS radius. If the number of these points is greater than or equal to minute points, a new cluster is formed. 3. Expand the cluster. Once a cluster is formed, DBSCAN continues to check the neighboring points. If any of these points have enough neighbors, they are added to the cluster. 4. Repeat. This process continues until no more points can be added to the cluster. 5. Identify noise points. Any points that don't belong to a cluster are labeled as noise. These are outliers that don't fit into any of the defined clusters. Let's illustrate this with a practical example. Imagine you're a scientist studying a population of animals in a forest. You collect data on their locations, and you want to identify groups of animals that are living closely together. Using DBSCAN, you set your EPS to 0.5 kilometers and minute points to 5. The algorithm will start from a random animal's location, find other animals within the 0.5 kilometers radius, and if there are at least 5 animals nearby, it will form a cluster. It continues this process until all animals are classified into clusters or labeled as noise. This means that DBSCAN can help you find distinct groups of animals, while also identifying any lone animals that might be outliers. Now, how does DBSCAN compare to other clustering methods like k-means? Well, one of the biggest advantages of DBSCAN is its ability to find arbitrarily shaped clusters. K-means, on the other hand, works best with spherical clusters. Also, DBSCAN can handle noise effectively. If you have data with outliers, DBSCAN can distinguish them from the main clusters, while k-means might misclassify them. However, DBSCAN does have its limitations. For example, it can struggle with clusters of varying densities. If one cluster is dense and another is sparse, DBSCAN might not perform as well. So, there you have it! DBSCAN is a powerful clustering algorithm that works by examining the density of data points and is particularly great at identifying clusters in complex datasets. To recap, DBSCAN uses two key parameters, EPS and minute points, to find clusters based on density and can effectively handle noise and outliers. Whether you're analyzing animal populations or customer segments, DBSCAN is a valuable tool to have in your data science toolkit. If you found this video helpful, please give it a thumbs up, subscribe to our channel for more educational content, and let us know in the comments what topics you'd like us to cover next. Thank you for watching, and keep exploring the amazing world of data science. Until next time, happy clustering!